Hey everybody, today we're going to take a look at ray fans and try to get an intuitive feel for what they are. So let's open up a Cooke Triplet and go to this education tab, which is a tab that I have in development where I'm planning on adding more buttons to showcase different optical concepts and give you a visual feel for them. So open up ray fan and let's look here. So pay attention to this graph here and this graph here. Let's hit sweep, and what you'll see is that we're sending rays through different heights on the pupil, and the pupil is basically the bundle of rays that we're sending through our system. So in this 2D view here, we can see three pupils or three fields. The on-axis one, which is in blue, a green one, which is off-axis, and an orange one, which is even more off-axis. And as we sweep through on a ray fan, we're basically plotting on the x-axis where in that pupil we are. And on the y-axis, we're going to plot our transverse aberration. And that is how far away from this paraxial point the ray lands in an actual image. So let's start by going to defocus over here and hitting sweep. So what we're doing in defocus is we're taking the image plane, which should be here, and we're moving it back, or we could also move it forward if we want. And what that's going to lead to is going to lead to a sloped, like a straight line sloped ray fan. And that's because when we're too low, the ray is going too far and it's going to land too high up, and that's going to lead to the point being above zero. Whereas when we go to the other side, it's going to end up too low, also because it goes too far. And that's going to lead to a negative transverse aberration here. The next aberration we'll look at is spherical aberration. And if we sweep that, you can see it forms a kind of cubic looking graph. And that's because in spherical aberration, as we send a ray too far away from the center, rays farther away from the center are going to focus closer than rays that go straight through the center. So you could see this ray, which is going pretty high up on the lens, is focusing right around here. And if we go towards the center, you can see they focus towards the paraxial point. And that leads to this cubic shaped graph. Next, let's go to SA plus defocus. So what this is doing is, if you look at spherical aberration and we sweep, you'll notice that right up here, the pupil seems a lot bigger than it is back here. So you might be wondering, why don't we just move the plane back here and have a better image? And that's what we're doing with spherical aberration plus defocus. So in defocus, we're moving the plane away from the paraxial location. And that's what we want to do with this spherical aberration. We want to move the plane back. And what that's going to look like is it's going to look like adding a positively sloped straight line graph. This is negatively sloped because the image plane is too far away, but here we want to move it closer. And so when we add that positively sloped graph to this, they're going to kind of cancel each other out. And they're going to lead to a more moderate graph like this. And you can see that at some points like here, yes, the normal spherical aberration without the defocus is better, but most of the time it seems like it gives a more moderate graph. And if we sweep, we'll see what that looks like. We just moved our plane up to a more reasonable spot on this graph. Next, let's look at coma, and we'll sweep. Now what coma is basically points that are hitting at a greater height on the lens are going to have a different magnification. But for an on-axis point, there is no magnification because the point is right at the middle, so it doesn't get magnified. So we have to go to an off-axis field to actually see this happen. And that's off-axis just means that it's coming in at an angle, so the point isn't going to be like directly on the axis, the optical axis of the system. So let's trace here, and now we can see the coma actually starting to do something to our system. Again, at 0 degrees it doesn't do anything because we're not really magnifying that point, but here we are. And that leads to this graph, which looks cubic at first, but in reality it's a parabola that changes sign right here. So we'll leave astigmatism for later. Now we'll move our attention up to this graph here. And this is basically a 3D view of the difference between tangential and sagittal ray fans. So if we open up an actual ray fan, you can see that we have two columns, tangential and sagittal. So what's the difference between these columns? Because you can see that the graphs are looking pretty different. Now, for an off-axis field, you have your optical axis and you have your field direction. And the tangential plane is the plane that contains both lines, the field line, this one, and the optical axis. The sagittal ray is the one that's perpendicular to that, or the sagittal plane, sorry. So as we sweep, you can see that for some aberrations, such as spherical aberration, it doesn't really make a difference whether you're on the tangential or sagittal plane. You can see that the graph looks the same. But for other aberrations, such as coma, you can see that it looks a lot better for sagittal than it does for tangential. It's actually 3 times worse than tangential. That's a kind of a geometric thing that happens. So now that we understand that, we can look at astigmatism, and that is basically tangential and sagittal rays focusing at a different point. So you'll see that if we're in tangential right now and we sweep, you can see that the actual points, or the rays, are focusing up here. But if we go to sagittal, so for tangential, it looks like the image plane is too far away. But for sagittal, it looks like the image plane is too close. They seem like they'd be focusing out here. So in reality, since you always actually have tangential and sagittal rays hitting the lens at the same time, you're going to just put your image plane kind of in between the two so that you kind of like damage control and don't get like a horrible circle for one. And that's what astigmatism is. It's when you have a different focus for tangential and sagittal rays. And what that looks like on a ray fan is in the tangential, you're going to have a negatively sloped ray fan. And on the sagittal, we're going to have a positively sloped ray fan. So now that you understand that, we can take a look at some of our actual ray fans. So let's open up our Cooke Triplet, which we already have open, hit ray fan, and take a look at some of these. So this here, this waviness is spherical aberration. Now, I know it looked like a cubic in that demonstration, but in reality, it's a very complex function, and you can take a Taylor series of them, and oftentimes, most of the aberration is going to be in the cubic term, but in some cases, such as this one, apparently, there's also some aberration in later terms. So you can see it looks more like a quintic graph, seeing that, the red, it kind of changes slope too many times to be a cubic. Here, in the 14-degree field, you can see that it's sloped up, and that's defocus right here. But in the sagittal, you can see that it seems sloped down almost. And that might be astigmatism, because we have a positive slope in one and a negative slope in the other. And then here we have what looks like spherical aberration. You can see this one looks like a cubic. And you can see that it's actually different for different colors. And that's an aberration called spherochromatism, which is basically different levels of spherical aberration for different colors. And we can open up other systems too and look at the ray fans. So I'll just open up a Heliar, which is a very, very well-corrected system. And we'll go to analysis and ray fan. Oops, wrong one. And you can see here, first of all, the graphs look kind of funky, but if you look at the actual scale, this is 4.0 times 10 to the times 10 to the minus 3. Whereas if we go to our Cooke Triplet, to the ray fan, it's times 10 to the minus 2. So the aberrations in the Heliar are like a tenth of the size, roughly, of the ones in the Cooke Triplet. But they are still there, and we'll take a look at them. Now, you can see some of these graphs are looking pretty complex. This one, you can see it looks like fifth order spherical aberration. You can see this looks like a quintic, I think. Maybe there's a bit of defocus too, because it looks like there might be a slope to this. But in reality, ray fans are the superposition of a lot of different aberrations. So you might have some defocus added onto some spherical aberration, added onto some coma, and that leads to some pretty complicated graphs sometimes. But the ray fan is a really great tool for kind of getting a quick look at what's dominating. So again, for that Cooke Triplet, you can see there is a lot of spherical aberration. There's some defocus. For this, it looks a little bit more complicated. You can see it doesn't look like there's too much astigmatism because the graphs look pretty similar between the two. So yeah, hopefully that gives you a better view of the ray fan. And if you want to try it out yourself, you could get Trefoila at trefoila.com. And I hope you enjoy it. I'll see you in the next video.